Hi, welcome to our math. Today I'm doing a series of videos on solving equations, and these are specifically equations with all those lovely fractions. Whenever I have problems with fractions, what I like to do is I like to clear the fractions. So to clear the fractions, the first thing I need to do is count up my terms. This is a little trickier. 4/5 m is a term, 2 is a term, and while we have parentheses over here, 2/3 times m plus 8 is a single term. Parentheses force a term. Until you get rid of those parentheses, that is a single term. The reason we need to count our terms. I want to multiply by my least common denominator to clear my fractions. Well, if I start counting at 5, 3 doesn't go into 5. I start with my bigger denominator. 5 plus 5 is 10. 3 doesn't go into 10. 10 plus 5 is 15. 3 does go into 15. So I'm going to multiply 15 over 1 to each of my terms. Now, I can't get into the parentheses. This 2/3 is like a jailer. That's why this is a single term. The 15 can multiply to the jailer, the 2/3, but the 15 cannot enter the parentheses until we distribute in. We haven't distributed in yet. That means the 15 multiplies to the 2/3, nothing inside the parentheses. Okay. Before I multiply, I'm going to reduce, I'm going to divide. 5 divides into 15 3 times, and 3 times 4 is 12. 2 times 15 is 30. 3 goes into 15 5 times, and 2 times 5 is 10. And the m plus 8 is not touched because they're still in jail. All right, let's break them out of jail. Let's distribute this 10m. 10 in. Okay, we have 12m plus 30 is equal to 10m plus 80. All right, I'm going to subtract 10m from both sides. I'm going to subtract 30 from both sides. 12 minus 10 is 2. 30 minus 30 is 0. 10 minus 10 is 0. 80 minus 30 is 50. When I divide both sides by 2, then m is going to equal 25. Awesome. Okay, so we have our answer. Let's look at our next one. Again, step 1, count the terms. 3/5 p, 2/3, 4/9 p plus 11. One term until we get rid of the parentheses. All right, least common denominator. Let's start with that big number. Let's start with that there 9. 5 does not go into 9. We don't have to worry about the 3. 3 goes into anything 9 goes into, so the 3 we get for free. If 9 goes into it, 3 goes into it. So we're really just looking at the 9 and the 5. 9 plus 9 is 18. 5 does not go into 18 because 5 only goes into things that end with 0 or 5. 18 plus 9 is 27. No. 27 plus 5 is 36. No. 36 plus 9 is 45. Ding, 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 ding. Multiply 45 over 1 to each of my 3 terms. Okay. Phew. For my first term, 5 goes into 45 9 times, and I end up with 9 times 3, and 9 times 3 is 27. P. 3 goes into 45 15 times, and 15 times 2 is 30. 9 goes into 45 5 times, and 5 times 4 is 20. And though it's still not the prettiest problem, it's a lot prettier than it was with all of those fractions. I'm going to distribute my 20. 27p plus 30 equals 20p plus 220. I'm going to subtract 20p from both sides. I'm going to subtract 30 from both sides. I'm going to end up with 7p, 0, 0, equaling 190. And when I divide by 7, 7 doesn't go into 190. P equals 190 over 7. I like my answers, my fractions, improper and reduced. To me, this is the star attraction of an answer. If you have a teacher who wants you to have a mixed number, you need to take 7 and divide it into 190. 7 goes into 19 twice. 14, remainder of 5. 7 goes into 57 times, 49, remainder of 1. And so the mixed number answer is 27 with a remainder of 1/7. And that would be your mixed number. I prefer my fractions, there we go. I prefer my fractions improper and reduced. That way I only have one set of rules. I know there are teachers out there who want the mixed numbers, so just know which way your teacher wants it to go. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on the next video. Thanks.